Okay, so now we're going to talk about the standardized score, all right? And with that, we're going to talk about the definition of a z-score, which is sometimes used interchangeably with a standardized score. Z is the symbol for a standardized score, and it reads like this. The z-score is the number of standard deviations a data value is from the mean. Okay, now how do I use that in context? Let's take a look. It says the class average for a Chapter 1 exam was 83, and I had a standard deviation of 7.8. Sally, who was in the class, earned an 86. Okay, so two questions. What is their z-score based off this information, and what does that mean in context? All right, so I'm going to say z is equal to, and I'm going to use the formula that you have above. Okay. X is the item in question, and in this case, we're asking about a score of 86. Okay. Minus the mean, which we said was 83, all over the standard deviation of 7.8. Okay, so you can do the quick math, do it in your calculator, and you'll get 0.3846. Okay, and that is Sally's z-score for her score on the test with respect to her other students. Okay, and what does that mean? It means Sally's test score for Chapter 1 was 0.3846 standard deviations okay, and since it's a positive, I'm going to say above the class average. Okay. If it were a negative, then instead of saying above, you would say below. All right. Now, the next question I'm going to ask relates to percentile, and you're going to do more of this work in 2.2. Okay. However, I want to tie this into what we've been doing in the beginning of this lesson, okay, which relates to percentile. And in order to do this next piece, I'm going to have to keep this number in mind, 0.3846, and apply it to a z-table. Okay, this is called the standard normal probabilities for a z-score. And so we said z was 0.3846, okay? And the nice thing about this is I'm going to round quite a bit here. I'm going to round this just to two place values past the decimal. So if I have 0.38, I'm going to look at the number behind it, and it is a number less than 6, okay? Sorry, less than 5. And so it'll just be a 0.38. Okay. Now I'm going to move my head up just a little bit and get myself out of the way here. Maybe I'll put myself in the middle. There we go. And I'm going to look up the score. And the way I do that is I have to have a kind of like a ones position. I have to have a number here. And so since I don't have one, I'll put a 0 there. And what I'm going to do is I'm going to look up on my chart this 0.3 that you see in the front. And if it were negative, it would be on the left side. Okay. And if it were positive, it would be on the right side. Okay. So these are the positives. These are the negative z-scores. And negative, again over here, positive 0.3 is right here. Okay. Now with that positive 0.3, there's a bunch of solutions behind it that represent probabilities. I want the one that ends in an 8. Okay, so I need to look up the one that ends in the 8. If you look up on the top row here, 0.08 is in this location. And then you have to pretend you're a kid and you're playing Battleship. Okay, you're going to follow this row, okay, along with this column and figure out where they meet. Now, on my presentation here, I can circle this because I know in the end I can erase it. On your sheet, which you have been provided with an attachment, you do not want to write on it, okay? It's something that you're gonna have to keep from now until the end of the year, past your AP exam in May, okay? So don't scratch it up, don't write on it, just kind of use your fingers and get the number. And in the end, you can see that that is 0.6480, and I am gonna write that as an answer. okay, and set it equal to a p. Okay, and what does that mean? That is a percentile. Okay, Sally, okay, scored in the, or maybe at the 64.8 percentile. Okay, with respect to her test scores. Okay, and what that means is her test score was better than 64.8 of the other students who took the same test. Okay. All right. Are you going to be asked a lot of this? Probably not. You'll probably see more of that a little bit later on in 2.2. Okay. It's more about just answering it this way. Okay. Just knowing that her score was 0.3846 standard deviations above the mean for all the students who took the same test as her. Okay. This is just a little attachment that kind of ties everything in from what we did at the very beginning of this lesson to now. Okay. All right. Last one, dealing with the same type of work, and I'll get my mug out of this way again, if I can. There we go. All right, and again, same formula. I didn't take it away, so you can still refer back to it. And it addresses two restaurants. We have one called Costa Vida, okay, and the other one's called Cafe Rio. They both serve Mexican food, and they're fantastic. Both of them are. The first one has a mean lunch participation, I guess, of 164 people. Okay, and standard deviation of 16.6. Okay, Cafe Rio has less. Okay, they have a mean of 124 and a standard deviation of 12.6. Okay, what I want to know is, well, looks like Charlie works here. Okay, and Lucy works over here. Okay, on Charlie's shift on a Saturday, okay, he had 150 customers. I take it back, 180. Okay, Lucy had 150. Okay, now Charlie had more than her. Okay, but comparatively speaking, based on where they work and what a typical day is, who had the busier day compared to what they're used to? Okay, so here's what I'm gonna do. I'm gonna make some information about Charlie and present it in the form of a z-score, and I'll also do one for Lucy. Okay, so Charlie's x value, okay, for his respective day, the one day in question is 180, and I'm gonna subtract the mean, 164, all over 16.6. And Lucy had 150. That was her score in question, minus the mean over the standard deviation. Okay, so that's the setup for each. Okay, that's confusing. Take a look at what we have over here. Okay, and pause it if you need to, just so that this makes sense. Okay, when you do this math over here, and do all the work, do the subtraction division, you'll find that you get 0.96. Okay, when you subtract these, you get 16 over 16.6, which is 0.96. And for Lucy, she has, looks like 26 over 12.6. Okay, which turns out to be 2.06. Okay, now based off these results, you're kind of done. You could be done if you want. All right. If I asked at this point who had the more busy day, you would say Lucy, okay, at least compared to what she's used to, okay? And the idea is that her amount of customers was a little bit more than 2 standard deviations above the mean compared to what she's used to, whereas Charlie was a little bit under 1 standard deviation from what he's used to, okay? So Lucy had a busier day. okay, compared to her we'll just say usual lunch crowd. Okay, because her standard deviation, her z-score, sorry, was higher, not only higher, but further away from the mean, okay, than Charlie's, okay? I'm out of space. Okay, and there you go. Let me go back to that just so you can write the rest of that down in case you missed it, okay? Again, look who has the bigger z-score. His was 0.96, hers was 2.06. Because hers was a little bit higher compared to Charlie's in a more positive direction, it means she was a little bit busier compared to what she was used to, okay? If you want, you can look them up further and answer more specifically. Look up, I'm gonna go back here, 0.96, okay, which is your 0.96 is about right here, which means Charlie's day was in about the 83rd percentile, okay? Lucy, which was 2.06, okay, was in the 98th percentile for busiest days of all days, okay? So yeah, she had a rougher day compared to what she was used to based off previous data, okay? All right, there you go. There's the work if you want to see it again. And pause that if you need to write some more stuff down. And this is the assignment that I would give you, okay? I hope you have a great day, and we will talk to you soon.